Seaborne datasets represent diverse data types in their columns. Primarily, we encounter numerical data, like age or price, which can be continuous or discrete. Then there's categorical data, such as gender or city, representing distinct groups.
Less commonly, we might find date-time objects. For illustration, consider the total_bill column from Seaborne STIP's dataset. This is a classic numerical, continuous variable. In Python, a Seaborne histplot of total_bill would be our choice. We use a histogram because it effectively visualizes the distribution of a single numerical variable. It clearly shows the frequency of different bill amounts, revealing the data's spread, central tendency, and overall shape, like if it's skewed or has multiple peaks. It's the ideal plot for understanding how a continuous variable is distributed.
The example uses Seaborne's built-in TIPS dataset to demonstrate different data types. First, it loads the dataset into a pandas data frame. Then, it prints the data types of each column using tips_df, dtypes, which is a common way to inspect the structure of a data frame. This output helps identify whether a column contains numerical, e.g., float 64, int 64, or categorical, e.g., object, category, data, which dictates how we can analyze and visualize it.
In the TIPS dataset, we observe various data types. Total_bill and tip are numerical. Float 64, representing continuous quantities. Size is numerical. Int 64, representing discrete counts. Columns like sex, smoker, day, and time are typically represented as object, string, or category in pandas, indicating categorical data with distinct, unordered values. Recognizing these types is crucial because different analytical and visualization techniques apply to each. For illustration, we chose total_bill, which is a continuous numerical data type. A histogram, SNS, histplot, is an excellent choice for visualizing the distribution of a single numerical variable. It divides the data into bins and counts how many data points fall into each bin, then displays these counts as bars, adding a kernel density estimate, KDE, curve, KDE equals true, provides a smooth representation of the data's probability density.
As you can see in the generated plot, the histogram clearly shows the distribution of total_bill values. The bars indicate the frequency of different total bill amounts, and the KDE curve overlays a smooth version of this distribution, helping us quickly identify common bill ranges and the overall shape of how total bills are spread across the dataset.